because at the end we do also have a Q&A section where you guys can ask your questions, and Dr. Shalan will, to the best of his ability, answer your questions. And in terms of the certificate of attendance, there will be one for this presentation, and you will get that to you within the next 4 business days. It will be in your email, but if you don't find it in your inbox, kindly check your junk or spam mail. It could be there. And if you don't get it, you can just send us an email and we can send it to you, as well as the copy of the slides. Those will be sent to you within the next 2 business days, along with the presentation itself. So just to give you a little bit of information about what ECT is about. So we are an engineering specialist. So we are affiliated to the well-established Engineering Institute of Technology, which is located in Australia. So what makes us special is the fact that we've got industry-driven programs with world-class accredited education, and that's all made possible by our lecturers and instructors who are specialists in the industry and have industry experience. So what also sets us apart is the fact that we've got a unique delivery model. And for this presentation, if you guys could just follow my instructions, we'll be fine, so we can move along smoothly. And now, today's topic is advanced maintenance practices of complex manufacturing assets. So this, like I've mentioned before, it will be presented to you by Dr. Abdul Shalan, and he's our industrial automation program leader. So if you don't mind, Dr. Shalan, you can go through the agenda and continue. You can take control of the screen.
Thank you very much, Komo. Really appreciate it. Thank you for the introduction as well. So before we start, well, hello everyone first. My name is Dr. Abdul Shalan. I am the program leader for industrial automation undergraduate and postgraduate programs at the ECT. My background, starting from my bachelor degree, was mechatronics engineering, and then master's in engineering management.
Sorry to interrupt you, Dr. Shalan. Would you like to take control of the slides, or would you like me to do it for you on my end?
Yeah, let me see. Here we go.
Okay. Perfect. There we go. Perfect. Thank you.
Thank you, Komo. So, as I was saying, my background starting from undergraduate degree in mechatronics engineering, master's in engineering management, and a PhD in advanced maintenance practices and automation systems. I did hold a lecturer role before I joined the ACT at the University of Sunderland in the UK, in the northeast cold of the UK. So I was teaching undergraduate, postgraduate degree apprentices modules, supervising PhD students, did carry out multiple projects and consultancy projects with different companies ranging from wide range of industries, including the automotive, oil and gas, food industry, you name it. So throughout my career and throughout my work, I did manage to link how industry can be reflected into academia and vice versa, and how academia actually is quite disconnected from what the industry is looking for or the actual industry practices that exist. Found out that academia is quite advanced and academia is quite disconnected in the way that academics will always look for top-end practices that are not really reflected in industry. And you will notice this if you are from a professional background, that whatever you hear in the news or at the big companies do not really or does not really exist at the SME levels. And SMEs are the engine behind our industries in general, because SMEs are the ones that supplies big companies and regular consumers with different parts, components, and different goods from lower tier products. So that was interesting to establish what is happening in academia and what is happening in industry, and how can we bridge out this gap. So today's topic is about advanced maintenance practices and how maintenance is quite an essential element, especially with the rapid modernization of manufacturing equipment. And we'll see how can this be identified. So main topics we're going to discuss today is going to be maintenance spendings, trends, modern maintenance practices. We will have a look at some case studies. One of the ones that I did work on, subsea cables manufacturing, changing in awareness, attitude and skills, different incidents that are related to poor maintenance, what is the neglected maintenance, and what would be the next step in this. To start with, why do we look at maintenance? Because maintenance is costly. If we started to look at Europe, it has 300 billion annual spend on maintenance. It employs 3 million people. In the UK only, it has 22 billion annual spend average on maintenance. So looking at these numbers and these figures, whether it is spendings or people that are working in the sector, that is a big sector. We never usually think about maintenance. It's not something that crosses our minds whenever we are buying something, whenever we are trying to use something. It is not something that it's not something of our interest. It's not something we give attention to at all. Because we say, oh, well, it is going to last, and if it did break, I'm just going to change it. And that's because it is relatively, generally, cheap product, something that is not going to have an impact on your operations, on your daily life, or whatever. Let's say if you are thinking about whatever you might have at home, or your day-to-day equipments or gadgets that you might have. So the impact of something going wrong or something breaking down on you yourself, it's not going to be a very highly impacting element. So you never really think about how am I going to maintain it, how am I going to look after it, or stuff like this. Other people would do, and this will be one of the main driving decisions for going for one product over another. And we can start to see this, and this is maybe within our daily life, is happening, let's say, with Chinese cars and the Chinese products in general. We started to see that it is fairly cheap, but how long is it going to last? How much are you going to spend to keep it lasting or to keep it running? If you started to look at the automotive sector, and I'm going to try to refer back to the automotive sector and cars in general, because this is something that all of us can relate to. We all had cars, driven a car. Our parents had a car at some point in life, and we know how it works. So you start to see that, well, if you started to look at maybe a French car, like a Peugeot or Citroën or something like this, and compare it to a Toyota car, for example, you start to see a huge impact or a huge difference in reliability. It's always said that the Japanese cars will last forever and they will never die. But if you had a French car, it is usually going to break within the first 5 years. And you might need to change it or to spend a lot of money in order to keep it running. And this is an element that lots of people might think of, and some of them might not. It depends on your knowledge and your views on planning for the future and what the future is going to be hiding for you whenever you are going to certain products over another. We are going to discuss a few things, and we are going to look into what are the trends that is related or that are related to the manufacturing sector. In order to know a little bit about what are the trends, we have to go a little bit back in time. Going back in time, we need to start to think about how things used to be made and where it used to be made. So starting from the first industrial revolution, and this is quite a little bit back, so the 1800s, and that's before any industrial revolutions came around. Let's start to think about how things used to be happening. So in the past, what we used to have someone in our town or in our city that is making products for us, and we used to buy out of this crafter. So if you wanted a table, you would go to that carpenter in your town and you will ask this carpenter to make you a table. That carpenter was only exposed to the people in town. So there was not that much of means to access different markets. It is just my town, my city, my village, whatever it is. And I'm just making it specialized for my customers that are around me. So customer base was limited. And products as well had that element of customization. So you would go and ask for a table that has a certain shape, certain color, certain engravings, whatever you want. Things started to develop with the industrial revolutions, and that's happened with the introduction of steam engines. So we started to have accessibility to different markets because we started to have steam trains. We started to have steam-powered ships like the Titanics. And similarly. So we started to have access, or that carpenter started to have access to different cities, different continents, different countries. So customer base increased. With this, there was the introduction of production lines. So that carpenter now is not just waiting for you to come around and say, I want a table with this size and shape and criteria, rather than that carpenter, and this started with Ford, decided to create a production line and make one model. And if you remember the old black and white movies where they had only one black car, that Ford guy decided that I'm going to make one car, I'm going to streamline it, I'm going to make a production line for it, I'm just going to sell only this car, and whoever wants a car, they can only buy this car. No difference in characteristics, criteria, options, wheels, colors, whatever it is. And because now I have accessibility to everywhere, I can ship these cars everywhere. So it is better to streamline it, make a production line to make only one product and ship it everywhere. Things developed later on when we started to have technology and industrial automation, which came around the 60s. And this was at the time when we had computers as well. So things started to be more technological, let's say. And we started to have a little bit of customization elements. So going back to that car example, so started to have a little bit different colors. And still until now, you still have very limited trims that you can get whenever you are buying a car. What can you get out of a different car? So if it is on one new model, you can't really customize anything. Rather than, well, you have a couple of options. Well, top tier, middle tier, lower tier, few colors that you can choose from, and that's it. Because still technology is limiting how much customization can I apply, and this will be related to cost as well. And you can see that is reflected when you are buying a Rolls Royce, for example, and you want to customize everything. It is going to take a long time and it's going to take a lot of money. And this is because you want to customize it. So this is the gives and takes for each of these different, or the trade-offs that you might have. With such development, you started to see that, well, because I have access to bigger markets and lots of people can buy my stuff, now I need my machines to work longer. So instead of working 1 hour, one shift from 9 to 5, I wanted to work 24 hours shift, 24/7 on machine that is just producing parts. I don't want to really spend money on buying new machineries, so I'm just going to keep this one running and running and running, override it until it dies, basically. And with this, there was that neglect of the asset failures. So in the past, because we didn't have that much accessibility, so even if my machines did break down, I don't have a lot of pressure to develop, to make parts or to make anything. So an impact of this was just, it's fine, I'm just going to wait until someone comes to fix it, or my maintenance person is going to come and fix it. But with such development and such pressure, and to keep the machines running and to make parts and to have delivery schedules, etc., we started to see the impact when the machine stops. So if a machine is breaking down for a day, a week, an hour, that's going to be impacting. refer back to the automotive industry, a car's manufacturer typically makes a car every 30 seconds. So if that production line stopped for whatever the reason, so they are losing a car every 30 seconds. And this is, for example, like where I am, where Nissan is. So you can start to think about, well, even for an hour of breakdown or line stoppage, that is going to be hundreds of thousands of pounds in losses. We started to look at expertise, and in many different countries, like Germany, for example, we started to have an aging workforce. People started to not want to be working, or that's how it's called, the blue-collar people started to decrease, and more of the white-collar people that wants to be in offices and working behind the computer. This is the trend that is happening now. So we started to see, and this is happening now as well, for example, where in the US, they can't find people to, they can't find mechanics to work in the workshops. And even in the UK, if I want to take my car to be fixed, I have to wait for weeks in order to find an appointment. Within the manufacturing in Germany, it's an aging workforce that is very common for years and years now, and they can't find replacements for this. We started to see technology is evolving very rapidly. So new technologies are coming out every year, every day, and industry can't really catch up with this how it should. Many different aspects. Well, what is the knowledge that is required? How can we do it? How much is it going to cost? How are we going to manage the transition to adapt such technologies? And with this, we started to look into the practices. So we started to think about, well, it's not working for me to have my assets working for forever without having any maintenance. So I need to start to look into how can I apply some maintenance applications and some maintenance strategies in order to keep it running. So these are the common trends that are happening at the minute. So some maintenance related trends, we started to see rapid changes over the past 20 years. We're going to come into the different maintenance strategies in a second, but you start to think about, machines were simple. We just work in it until it breaks, and then I'm going to fix it. No problem at all. But now we started to think about how can I keep it running without having any sudden breakdown. So increased in awareness, and with this, we started to see with the complexities of machinery. So machines are not simple anymore. It's not just a mechanical system that is doing whatever it should be doing, rather than it is a very complicated, sensitive platform. Think about how it is with any machineries if you are working and how complex it is. You would definitely have, if you are an expert or if you are working engineer or working in a factory, there is an asset or there is a main asset that is the drive for the entire company that makes the essential parts of the job. And these assets are very complex, are very costly to buy, and needs to be running efficiently. We started to see new maintenance methods, strategies, ways of how can we do things differently in order to keep our cost down, our quality up, and our downtime down. We started to see changing views of the organizations and the responsibility of maintenance. Well, what should be doing, who should be doing what, and how can we involve everyone within our practices? Can the operators do some maintenance tasks? What management should be doing and encouraged to do in order to keep everything running how it should? So things started to evolve and different views started to come to the market. I wanted to show you an example of that subsea cable manufacturing. So have you ever wondered how the subsea cables are getting manufactured? The ones that delivers or moves around the internet cables, the power cables, the gas pipes, all of these that are buried under the sea. So to give you an insight, there are different or couple of types for making such subsea cables. So there is something called a vertical helix assembly machine, and there is a horizontal helix assembly machine. These two machines, I did work with a company on them before, and it is just, I thought I would just give you an example to show you how these machines are big. That vertical helix one that I'm going to show you, this is considered the largest manufacturing asset in the world. It is the biggest machine. It has a plate diameter of 10 meters and height of 52 meters. So I remember when I used to go there, we used to see the seagulls just flying on the top of the machine, and it's quite magnificent piece of equipment. And if you want to see, or if you need to know how things can be done, so you start to see that, well, this is a big structure that is moving. And you start to see all of these carousels that are responsible of feeding the different cables. So subsea cables, it's made of different bundles. So that bundle, it's a big bundle, and this bundle would have different cables or different arrangements of different cables, depending on the customer's requirements and need. And I want this bundle to be perfectly made and to be made in lengths that can go up to miles. So how can I make sure that this is the case? When you look at the video, you start to see that, well, each of these carousels, massive carousels, they have a feeding system. So how much should I feed certain cables? Each cable has certain elasticity. So I might stretch a cable or I might crump a cable. I need to keep rotating with certain amount based on the criteria of the carousel or the cable or the pipe on that carousel in order to keep everything tied nice and steady. So it's not an easy task. It is quite a complicated task. And in order to make this machine running for days, in order to make miles long of cables, that is really challenging task. And I'm not going to get into how this machine used to happen or used to work. It had all the types of issues. It was a very hectic piece of machinery and had to be stripped down totally and rebuilt, etc., because of the many issues that it had. But it reflects how maintenance is essential. It was neglected for a while, and because of that neglect, there was a big losses in products. So cables were out of spec. It was not really good for purpose. Cost implications was very high. Customers were not happy. There was very late delivery of every product or every product that can be made. So things were not really going how it should. And all of this is because of the poor maintenance practices. If we had a look at the horizontal version of it, excuse the videos that I used to take, it's not the best shots. But you can see as well, this is quite a big structure as well, and it is doing the same. So you can see all of these yellow parts on the top of it. So these yellow elements, these are the different carousels that are holding different cables and different bundles with different criteria and characteristics. So it's not just a simple machinery that is rotating, rather than that's quite a complex structure. And everything has to be working perfectly within specific feed, within specific criteria in order to make it how it should. And you can see here, this is, if you had a look at this gray area, this is the end product. This is what comes out of it eventually. It has many different cables with different arrangements that are coming together to give you that specific products. Think about if that subsea cable was not made well and had some sort of fault or a problem when it is buried miles under the on the ocean bed or the seabed. It is very costly. It is really costly to fix it and to go in the middle of the ocean to fix such a cable. So things used to be or had to be made in a perfect way. What did we start to have? We started to have a changing in awareness. So a growing awareness of how equipment failures affect safety and environment. So if I'm not making it, or if this machine is not working how it should be, let's say for example, your car. If your car is not really good or not maintained well, it's going to have a big impact on your safety. You might have a wheel flying off. You will have an impact on environment because, well, your car might be taking or burning more fuel, and you might see this when you see a car having this black or white smokes coming out of it. Well, this is an impact to environment. The same thing can happen to industrial machineries. It would emit different gases, different materials to the environment, and it might cause and be the reason behind having serious safety concerns. I used to work with a colleague back in the time, and that colleague was an old colleague, and that colleague used to tell me, in the past, when you are working in a factory, it is quite rare to find someone with 10 fingers. And that was a very interesting comment. And you start to think about why was that? It was because, well, there is no maintenance, there is no health and safety requirements, there is nothing. So at some point in your career as a worker or a blue-collar worker, you might lose a finger. And your finger will be tripped somewhere within some parts. And as a result, you will just, typically, it is very rare to have someone that has full 10 fingers intact. You started to see awareness of connection between maintenance and product quality. People started to realize, well, when it's not working how it should, my product's quality is going to be low. And with modern products in general, we started to have that. What is it called? Kind of a fight within the market between the different companies to make better products, because you're not the only one that is making cars, you're not the only one making mobile phones or making TVs or making whatever. So you really have to make sure that your product's qualities are high, and you have to make sure everything is working how it should. And there was that awareness that, well, we can see now that, well, maintenance would have a direct impact on product quality. If the machine is not working how it should, products are not going to come out with high quality. We started to see pressure to achieve increased level of equipment availability and maintain cost. We need the machine to be working for longer hours, and we need to control how much is it going to cost us and how much are we going to spend eventually. Everything, there is a competition in the market for our products. I am making mobile phones. There are 10, 15, 20, 100 other companies that are making mobile phones. In order to gain presence in the market, I have to make a better phone and a cheaper phone. So to make a better and cheaper phone, you need to look into all the losses that might happen. And this will refer back to the different lean applications and the different performance indicators and quality and stuff like this. So that's not the focus of today's webinar. But we started to see this, and because of this, there was a really good attention to maintenance recently. Related to the attitude and skills, we started to see maintenance staff have a need to adapt new ways of thinking. So one company I did work with in the past, and it was a big company, it was a supplier for Nissan, and when we were reviewing what you're doing for maintenance, you started to see that this maintenance engineer coming around, and the one that did set up the maintenance plan, and said, well, we created a maintenance plan that covers everything within the machine. So we are going to check on every single bolt and nut and cable and everything within the machine. But you start to think, is this a really good practice? Because if you start to take or to do all of these lists of requirements or checklists of different, the big long checklist of different things to do, that is a time that this machine is not working. So you're taking the machine off operation in order to check on all of these. And because it's a very big list, so you're not going to do it all in a good quality work. So you start to see that, well, now we start to think, or you have to start to think differently. You start to think in a way that what is important and what should I give the highest priority when I'm trying to adapt or develop a maintenance plan. What's important and what's not. Go back to our car example. So when you are doing your annual maintenance, routine maintenance, for example, you'll never see that the person or the mechanic is checking how your car seat or the seat inside the car is bolted properly, or if the light inside your cabin is working or not. But that's not really an important element. If the light went off, or if the seat went wobbly a little bit or whatever, that's not impacting anything. It's not going to impact safety. It's not going to impact the environment. It's not going to impact anything, cost, whatever it is. So some things you can neglect, and some things you can check on them on longer period of time. So instead of doing it weekly, monthly, quarterly, you might want to do it annually. So you start to have smarter maintenance plan. Other element was managers are seeking new approach to maintenance. What can we do differently? How can we do this in a different way? And this was developed and adapted by the different strategies that are coming around, which we're going to discuss briefly in a second. You started to see operators' involvement, and this is part of, or a main element of a maintenance strategy called TPM, or Total Productive Maintenance. So TPM suggests that, well, not every maintenance task is a complicated task that requires a specialist to do it. So why don't we get the operator that is running the machine to check on this, to do this, instead of taking valuable time of professionals to carry out such a task? And these are the different elements that started to highlight the changes in attitude and skills. Many different things we can talk about and discuss, but this is kind of a brief highlight. What can happen when we have poor maintenance? Let's have a look at some incidents. Within the UK, we started to see the Hatfield rail crash, which killed 4 people. We started to see a tube crash in London, and again, lots of people were injured. And you started to see the Concorde crashes that killed 113 people. And all of this is because of poor maintenance. It all reflects back on maintenance and how this maintenance task was carried out, how efficient and the quality of it was done, and was it even done or not. So you start to see, well, I need to really maintain it to keep it running and to avoid really serious implications. Because of these Concorde crashes, the Concorde disappeared in general. So we started an entire state-of-the-art plane does not exist anymore because of poor maintenance. So it gives you a way and things to think about. So, as I keep saying, I'm going back to the core example all the time because I'm not really aware of your backgrounds or what you do. So cars is quite a common ground. So think about a car and what must be done to keep your car running. You need to change the oil. You need to look into the filters. You need to look into the belts and hoses. You need to look into your tires. You need to have a clean wash inside and out. Why do you clean it? Why is it a maintenance thing? Because when you clean it, you start to see things that were hidden behind the dirt. And this is the same if you started to see how in industry in general, it's a dirty environment, depending on which industry you are. But generally, you start to see factories are not really a pleasant place to work at. Typically with SMEs, well, they don't really care. So you might find a motor or a pump or a pipe or whatever it is covered in dirt, dust, grease, whatever it is. Behind all of this, there would be a failure, or there might be a failure, might not, but there might be a failure behind all of this rubbish or dust or grease that is causing you certain issues, causing you an increment on your energy bill, for example, causing you losses in pressures and performance, etc. Start to look at replacing the brake pads, regular inspections. So all of these are car maintenance related examples. What could be the implications of not doing it? You start to look at each of these elements and you start to see, well, I'm going to have different failures if we start to relate to all of this. If I didn't change the oil, the engine will seize and break down. If I didn't change the filter, I'm going to have blockages and I will have increment in fuel consumption. If I didn't change or check on these hoses and belts, something will snap and the car will stop midway whenever I'm going from point A to point B. If I didn't check the tires, might blow up and might have serious accidents. Same thing with brakes. Same thing with regular full around inspection. So kind of an implication as a summary. So you have premature failures, you have increased running costs because you will consume more energy. If you have a bad filters, bad engine, bad tires, running cost and the fuel consumption will increase. You will have unexpected breakdowns, it will break somewhere. Poor operator morale. So people are not really interested in doing it how it should. You would have personal injuries if you had any accident and you might die. So all of these are implications of poor car maintenance. you start to think now, well, maintenance is quite important. So what are the different maintenance strategies that we can do or carry out? In general, you have maintenance strategies and maintenance approaches. If you started to look at the approaches, the basic approach, which is nothing, is run to fail. I'm just going to keep using it until it breaks. It's not really a maintenance approach or strategy, rather than it is an attitude. Start to have time-based maintenance. And time-based maintenance, I have a plan, and this plan, like back to your car example, all of these things with the cars can be applied on manufacturing assets. Look into your car, you buy a new car, you have a logbook, and this logbook tells you what to do on 1,000 miles, on 10,000 miles, 20,000 miles, what should be done. This time-based is useful, and it can eliminate lots of the different risks, but it is still not accurate, not useful. Think about a car that is, if I have a car, you have a car, Lucy with us here has a car, and each one of us has different driving attitude. I drive in a very bad way, so I'm always pushing the car, revving up the car, and traveling long distances in country roads. Lucy, on the other hand, she's a good driver. She drives very small distance within the city. She doesn't drive for a long time, so it's only usually daily drive off, let's say, 20, 30 minutes, 15 minutes both ways, kind of a typical range of what she does. She's a good driver. She knows how to drive, and she is a very respectful person on the road, let's say. We should keep that logbook that was developed by the manufacturer, but that logbook does not really reflect our usage of that car. So my car typically will break earlier, and something might go wrong before that annual maintenance inspection comes around. So that time-based plan that was developed does not really suit my car or my usage. It might suit Lucy, it might not, because Lucy, on the other hand, she doesn't really drive that much. So if it is an annual inspection, because she doesn't drive much, she's a good driver, so this annual inspection should last her for 2 years. So instead of doing it every year, she can do it every 2 years, and it's going to have the same impact. So for my case, I needed more frequent inspections and maintenance, but for Lucy's case, she needed longer time. So for my case, I need to spend more money and fix it, or spend more money on maintenance to avoid sudden breakdowns. And for Lucy's case, what she wants, she's doing it every year, which is costing her double of what could have costed her if she's doing it every 2 years. So you can start to see that, well, time-based is not really tailored to everyone's usage, rather than it's just a general basic based on companies' data and analysis. So time-based is not really efficient in this case. We started to have development, so we have condition-based maintenance, so using different sensors to indicate different parts of the equipment and have different condition of the different parts of the equipment. So for motors, we started to have vibration sensors, temperature sensors. We started to have pressure sensors. We started to have a wide range of different things that can help us to indicate the performance and condition of our equipment. With this, we started to have as well strategies. And the strategy in general for maintenance, it is a collective of different things or different criteria or elements that if they were established or developed or used, all of them together, this is going to have an increment in performance. In a very basic way, because all of these different strategies, they are very big strategies. But if we started to look at RCM, reliability centered maintenance, this was developed by the Army back at the time, around the 60s, I believe, and it was mainly, and it mainly focuses on machineries. So how can I break down this machine, and how can I analyze it perfectly? How can I look into FMEA, if you heard about it? How can I look into every aspect that can be related to the machinery and make it work how it should? For TPM, or total productive maintenance, it is an organizational strategy. So it looks into the machineries, but in addition, it looks into the workplace, it looks into the people, it looks into management, it looks into different things. And the condition-based maintenance, it is more about the different types and ranges of sensors that can be used in order to monitor the conditions. So you have wired sensors, you have wireless sensors, you have IoT, you have control connected sensors within your control systems, you have externally connected systems. It's lots of different things that can be discussed and spoken about. So again, different ones, different applications, each of them can be applied on different scenarios, and lots of different companies, big companies, will create their hybrid strategy that mix and match between all of these different three. So again, it is back to how, what are the requirements and needs for each company. With this, we start to think about, well, okay, that's interesting. It's good to hear about all of this, but what could be the barriers to applying such a maintenance strategy? It's not just, well, there is a strategy, just go and do it. For TPM, for example, you need for up to 5 years in order to see an impact on performance, on cost, on different things. So some barriers would be limited staff, like how we've seen. Well, not many people are around in order to tell us how can you do it, in order to have the experience to do it or to teach people how to do it. Lack of training. You might have seen it. Well, you start a new job, you're just thrown into the workshop. Go and start with the work. No one gave you proper training. No one told you how can you do things. No one did set for you personal development plan to learn new things every time or every while. Inadequate diagnostic equipment, don't really have good tools that can help you to diagnose or to find out what's wrong. Missing technical documentations, and from personal experience, almost every company I did work with, they didn't have all the documentations that should be there for their machineries. Well, it is lost somewhere. Budget issues, no one wants to spend money. Every company would look at maintenance as an extra cost. It's not making money. I'm spending money on maintenance. What am I getting in return? They are not getting anything physical or anything that they can feel. So management in general, they don't really care about maintenance or give it its value. Inadequate monitoring of equipment. So I'm not really looking for, not using good equipment or tools to monitor the equipment's performance. I'm not having a good maintenance plan that tells me what should I do, when should I do it, how should I do it. Management are not really committed. You usually find managements in their offices, in their suits, and they have no idea what's happening in the workshop. And this is quite a disconnect between the reality and what the office is saying. And then poor morale. Poor morale when people are not feeling that they are part of this organization. I'm just going there from 9 to 5 to do my job and then leave. And you will see this with all the companies that treats their employees as assets and numbers. This is very common. We've seen this with Amazon, for example, and all the different hate that people have for Amazon because they treat people like just numbers. So all of these can be identified as barriers. Lots of other barriers can be discussed, again, for the sake of today's. What can happen when neglected maintenance practices take place? Operating equipment in manual override, you're basically ignoring what the issue would be, like how you would have with your car, and you just have a check engine light or a brakes light and you just ignore it. Keep driving the car. Incorrect adjusted equipment, inefficient operations, inoperative equipment, different leaks, whether it is steam, air, oil, water, chemicals, faulty control systems, increased costs, safety problems, all of this is impact of the neglected maintenance. But what can happen when we have good maintenance practices? You can have lots of nice things, all the bells and whistles. So you can have improved equipment efficiency, increased quality. Quality is going to go up. You can easily identify equipment defects, reduce the failures, increase the production rate, and make your customers happy. Improved safety, because machines are working how they should, so nothing wrong is going to happen, hopefully. Minimize the damage to the equipment, because, well, if one part did fail, this part is connected to something else, so it is going to break something else connected to it. Provide guidelines for new equipment purchase, because now you know what is going on, how can you use it, what are the different criteria and performance of this. So it's going to give you a really good feedback on your next purchase, what should you buy and what should you not. Effectively prioritize decreasing resources. So you're going to save a lot on resources. Improve staff morale, because staff can see that, well, there is really good, because part of maintenance practices was staff and staff development and the sense of belonging, stuff like this. So you're going to have increased staff morale. You can have reduced energy consumption, and the research shows that you might have a really good 28% increase year on year on energy consumption when you have your machineries working how they should. You can develop an energy management culture, and you can see how things can impact your savings, your surroundings, your community, etc. So, looking into all of this, start to think, well, what is coming next? Well, we've seen all of these different things, but these strategies, well, they are around since 70s, the 60s, the 80s, with different changes, minor changes. But you start to see an impact with AI. AI is everywhere. So AI can analyze data and can start to think about, well, what is going wrong and where the majority of issues are coming from, or what are they impacting really, and they can improve this. We started to have AR, and augmented reality and virtual reality, that can support people in training and carrying out certain tasks. You can look this up. Well, BMW did develop this since early 2000s, and there are different videos on YouTube that shows all of these, but different companies now is developing such systems that can guide you through doing certain tasks, that can train you and tell you, show you how can you do different tasks. New technologies, so we started to have all the different IoT applications, cyber physical systems, connectivity, robotics, all the data analytics and data collection and analysis. All of this is impacting how things can be done and should be done. So it is making savings, it is indicating and directing and showing where the issues would be and how could this be tackled in early stages. And all of this can be done with machine learning and prediction tools, for example, that can tell you, well, there is something that is going on here, and this is a trend or a coming up trend. So you might want to look at this at early stages before it has some serious impacts on your performance or in your operations. So I hope that was useful to you. This is, I think it's more of how can you get more insights into what is maintenance, what is maintenance and how it is done, how could it impact your day-to-day life. Think about everything that you might have if you're working, or if you're not working, think about your washing machine and maintenance of this, for example, if you're not. So I hope that was useful to you. If you have any questions, please ask. I'm always happy to answer your questions. We have a few minutes left in this webinar. Even if you don't, and if you had any later on questions, I'm sure Como is going to share my contact details with you. Send me an email. Let's have a discussion. We can have meetings. We can talk about whatever you would want to talk about if it is related to maintenance or automation and systems like this. Thank you, everyone, and I'm going to hand it back to Como.
Hello, guys. Can you hear me?
Yeah.
Thank you all for joining our webinar today, and thank you to you, Dr. Shalan. That was very informative, and I'm sure the attendees will agree. So in order for us to continue, I would just like to find out if there are any questions. Okay, sorry. I just saw a comment in the thing, but it's actually an AI note taker. I was like, what is this? But anyway, thank you all for joining. Do we have any questions? If you do, you can just put them in the Q&A box, or if you don't have the Q&A box, you can always type it in the chat. We've got about 10 minutes left for this session. But while we're waiting for you guys to think of any questions, we do have intakes coming up for June, October, as well as September. So September is for our bachelor courses. We are offering 2 at the moment, which is industrial automation and electrical engineering. And then for our master's programs, we've got the power system analysis and renewable integration, and we also have our industrial automation and did I say industrial automation and renewable integration? That's not correct. It's power system analysis and renewable integration, and then we also have industrial automation and instrumentation control for June and October intakes. And then for the certificate of attendance, we do have a QR code that you guys can actually just scan with your phones. Or alternatively, you can use this link that I've put into the chat box. So this link will basically send you to a place where you can just fill in a survey. Once you've filled in the survey, it'll capture your details, such as your email, and then we'll be able to send you the certificate of attendance along with the video and the presentation. I don't think we've got any questions right now.
Looks like it was either clear enough or complicated enough to not allow for any questions.
No, you did.
So
you did very
clear.
well. Yeah, it was too clear that there's no questions. So thank you all for attending, and have yourself a good day, the rest of the day or evening, depending on where you are in the world. But yeah, from my side, thank you. Dr. Shalon, thank you. Lucy, thank you for joining us as well.
Welcome.
Have a good
thank
day.
you everyone for attending. Have a good day.
Okay, bye.
Bye.